Okay, let's deal with this problem with phosphorus and see how we can solve it with a calculator. Again, we've got a calculator. When you turn your calculator on, think about the numbers that you're calculating. It does the multiplication and division quickly, but you've got to understand what's happening to really see if you did the problem correctly. Now, how many moles of atoms are in 0.696 grams of phosphorus? We've got the same mass, 0.696 grams, but we're dealing now with phosphorus atoms. Now, the phosphorus is this white solid, and if we move things over here, you can see what it is. It's an interesting element in that it has a number of different forms. This is a poisonous one that used to be used in matches that were called lucifers because they'd be covered in wax. When you expose them, they would instantly start burning, but very dangerous in terms of being toxic. Well, we've got a new atomic weight, so let's take our mass, 0.696, and divide it by the molar mass of phosphorus, which right here I see is 30.97 grams per mole. So I'll divide by 30.97. We divided by sulfur before, which was 32.06. So this is a lighter atom. And with that, we're going to have more moles. It takes more atoms to make up this 0.696 grams. So there's our moles, 0.022, rounded off 5, 3 significant digits. Leading zeros aren't significant. We want numbers of atoms. And whenever we want a number within a mole, how many of these things are in a mole, we would multiply by our 6.022 times 10 to the 23, that huge number, because there are so many of these atoms to make up this number of moles. That's why we picked this 6.022 times 10 to the 23, so we'd have a manageable number to deal with. That's our 1.35 times 10 to the 22. We'd expect a huge number of atoms to be present within even this small sample. And now we've got that answer. That's correct. And we want to know how many of these tetrahedrons, because these phosphorus atoms aren't individual. When they are around in this white form, they form a tetrahedron. So we want to know how many of these little tetrahedrons of P4s are within all of these atoms. And if there are 4 of those P's in every one of our molecules, we would just divide that huge number of atoms by 4 to find out how many little tetrahedrons are there, and that's our 0.33 times 10 to the 21. So we could have gone the route with finding out how many moles of P4, which could have been done this way. We could have taken our 0.696, and which are our grams, and divided by our atomic weight, which would be 4 times our atomic mass, which was 30.97. And that would give us our moles, our 0.00562 of our phosphorus. And we would say, okay, there we've got a smaller number of moles because we now are dividing by a larger molar mass. The molar mass of P4 is 4 times 30, which is 120. So instead of taking 0.696 and dividing it by 30, we're dividing it by 120, which is the mass of this larger tetraphosphorus molecule. And of course, we get our 6.022 times 10 to the 23 and get the same answer that we had, our 3.383 times 10 to the 21. Of course, in my calculator, I have an alpha n, which is my Avogadro number, and that gives me my 6.02 times 10 to the 23rd if I ever typed it in, but I did it the long way. So there's our method of using our calculator to get this answer.